to another video, guys. That's all about relative velocity and relative motions. So today we're gonna go through physics. This is the problem 2. Make sure you watch problem 1 dedicated to escalator. And also, if you want to see how to calculate the average speed, also make sure you watch the average speed topic. Alright, today we have a bit different problem. It's all about airplane. So right now you have city 1 and city 2. The airplane is flying from city 1 to city 2 and the way back means forwards and back with a speed of 400 kilometers per hour relative to the air. Okay, so it means here is the relative motion to the air. You are given the distance between two cities, 1000 kilometers. How much it takes for airplane to cover the distance, forwards and back. A wind blows with a speed 100 kilometers per hour. At first case, along the line, it blows along the line. It blows perpendicular to the line and at angle 30 to the line, connecting two cities C1 and C2. Pause the video, try to do by your own, and let's have a look at my explanation. So that's all about relative velocity. So make sure you remember, if you have, let's say, v of airplane and you have the speed of and velocity of wind, let mark as u, here's going to be they're both vectors because they are velocities. The resultant vector that takes into account the result of wind blown and on speed of the airplane when there is no wind, as we mark VA. So the relative velocity is going to be vector sum. So let's mark as VA of the airplane is going to be vector sum of VA and U. Because you have different cases, different orientations of vectors, you need to take into account not just as algebraic sum, but as the vector sum as well. Let's have a look at what we have in case 1. So here is the case 1. The wind is blown along line C1, C2. Let's have a look at the velocity of the airplane. Let's mark as VA. That's our velocity, which is equal to 400 kilometers per hour. And let's say first time the wind is blown against the airplane, so it means this way back. Okay, let it be the velocity. So actually I would like to draw proportionally. Okay, so for example, this is going to be smaller vector, around 4 times smaller, because that's around 100 kilometers. So that's going to be U, stays for wind. Alright, so that's also vector, and this is the vector. What we need to do, we need to calculate the resultant vector of the airplane. So we understand that, just take into account the previous case. I will show you quick how it can be done using the vector addition. Let it be green one. So that's going to be, we have basically connect VA with U. So here is going to be the resultant vector, and we mark as V airplane prime. It's not derivative, but it's relative velocity of the airplane, the resultant velocity that we will have relative to the Earth. Okay, so that means VA in the first case, when it goes from CD1 to CD2, prime is going to be VA minus, so in vector way it's going to be plus, but algebraically the resultant value VA C1 C2 is going to be VA minus U. Okay, if it goes the way back from C2 to C1, the relative velocity of the airplane, or resultant velocity of the airplane relative to the ground, relative to the surface of the Earth, is going to be VA plus U in that case. I've already got the value, and of course it's going to be greater. So let's calculate real quick. So the relative value is going to be 400 minus 100 is going to be 300 in the first case, and The resultant velocity in the case 2 is going to be 500. Okay, so that means we need to calculate the total time. So the total time is the total distance traveled by a wheel, take into account time from C1 to C2 and the way back. Of course, we will have different times, C2, C1. So as a result, let's mark D as the distance. So we'll get first the general formula. So D, when it goes from C1 to C2, is going to be D over VA minus U. And the second time, it's going to be D over VA plus U. And if you plug the values, you'll actually get the following. So 1000 is going to be distance, 1 over the difference, that's going to be 300, and plus 1 over 500. That's going to be a time measured in hours. If you calculate that, the time is going to be around 5.3 recurring hours. Okay, hours. And that's going to be the answer. Let's move to the problem B, where the question B requires here that wind blow perpendicular to line C1 and C2. Alright, so we marked the speed wind perpendicular to line C1, C2. So let's set up, so let's mark like this. This is going to be U, the wind, alright? So that's the speed of wind U. In this case, because we want to have your airplane flying from C1 directly to C2, the resultant vector, let's mark as the green one, is supposed to be in that way. So maybe just increase the font for that, for this arrow. So that should be the resultant vector. And it's supposed to be, sorry, for some reason it does work. So let's try and mark that, maybe it works better. So that's going to be resultant from here to here. That's going to be the resultant velocity of the airplane so that it sticks to the course from C1 to C2. So that's why the actual direction of how airplane should move is supposed to be that way. So let's put the yellow one, and that's going to be the actual velocity, VA, of the airplane. All right, so there are both vectors, and we have the triangle. So maybe it's better to use, let me see which color to use. Let it be black one. So that's going to be black resultant VA prime velocity that airplane will finally or eventually will stick to, so that to arrive from CD1 to CD2. Okay, so this is right angle triangle, and from there we want to figure out a side VA prime. So which way we can do VA prime is going to be a square root of VA squared minus U squared. So that's how it works, and that's basic Pythagoras theorem. So obviously the time, when it goes, by the way, let's consider the case right now when it goes backward. So when it goes backward, you should have the same VA prime vector for the actual motion of the airplane, so that while it's blown by the wind, it should have the same final resultant direction. So even if you have this as the actual velocity the airplane need to support or need to have in order to have the course from C2 to C1, okay? And that means U goes down is going to be U for the wind. As you can see here, the resultant velocity VA prime is going to be the same because that's absolutely the same triangle. So we can figure out the time for that. So time is double distance, right, over their velocity VA prime as we're looking for. Okay, so this is the bottom vector in that case. So we can easily calculate that. It's going to be double distance, so 2000 and over the square root of, or right now let's calculate it separately. VA prime is going to be square root of, let's calculate that quick. So that's going to be square root of 1000 squared minus 100, which is also squared. So that's going to be around 994. Wow, that's really the case. One more time, let's recheck. So this VA, one more time, VA prime, yes, it's VA squared 1. Oh wait, my bad. Why am I sound then? So it's going to be 5, it's going to be 400, okay? Yeah, so right now I've got the right number, I guess. 387.3 kilometers per hour. That's going to be VA prime. Hope you got the same. Just simply use that Pythagoras. And we divide by 387.3 in order to calculate the time required. So 2000 over 387.3. So we've got around 5 hours and 5.2 hours in that case. That's going to be time required for that. So in the last case, when wind is blowing an angle is 30 degrees to C1, C2. So let's put this vector, let it be vector U. Let's mark it as yellow one. So that's the vector for the wind blowing at angle 30 degrees. So here is the angle 30 degrees. Let's mark like that. So the airplane, in order to stick to the route, stick to the direction parallel to the segment C1, C2, and we marked as the black one. So that's going to be the real relative velocity, so that the velocity of the direction, let's say, of the airplane against the wind is going to be this way, VA. So that VA prime is going to be the vector sum of VA and U. Using the hat to tip rule. In that case, VA prime is going to be the sum, vector sum VA and U, and that's how we get direction of the real velocity as the black vector, VA prime, from C1 to C2. All right, but how to figure out the value? Of course, in that case, we arrange triangle. It's scalene triangle with some angle 30 degrees. So that's why it's much more convenient to apply the cos rule. So let's apply cos rule for this triangle. And because we know the angle between two vectors VA prime and U, we're gonna express VA from there as square the magnitude of their VA. In that case, VA squared is VA prime squared plus U squared minus 2VA prime U and times cos 30. Okay, so we've got quadratic equation with respect to VA prime from where we can express this value. So we plug all the values that we know. VA prime squared minus, so in that case U is going to be for 100, right? 100 kilometers, and that's U. So that means 200 over cos 30 square root 3 over 2. So that's why after simplification, we'll get 100 square root 3 VA prime. And then the rest parts, it's U squared. So we'll get 100 squared minus 400 squared. And that's going to be equal to 0. So another way to show, we can calculate approximate values. So minus 173.2 times VA prime and minus 150 thousandths in that case. So we need to solve quadratic equations. So let's express VA prime using quadratic formula. That how will work. In that case, if we calculate, there is only one root, one solution will be eligible. It's 483.46 kilometers per hour. So this is the way from C1 to C2. So let's move to another case when it travels from C2 to C1. So that's real direction. So in that case, but the wind is still blowing at the angle of 30 degrees. So that's why we put this vector u at an angle of still 30 degrees. But we need to arrange the motion so that the resultant vector is going to be from C2 to C1. Okay, so that's the actual direction of the airplane. So I put this vector in this way, so that's going to be VA prime. And that means that the real direction of the airplane is supposed to be in that way. Okay, so probably I just erased that quick. Reset up. So that's U. And that's, let's mark as blue one from here to here. That's going to be the actual VA velocity. So how to figure out the relative velocity V prime? So VA prime. In that case, we can set up the angle right here, which is 150 degrees, okay, because it's open angle. Basically, it's adjacent angle. So right now we can complete the same cos rule, for the vectors VA prime and U, because we know the angle between them. So we can express VA squared as VA prime squared plus U squared minus 2VA prime U and cos of the angle 150 in that case, 150 degrees. So cos 150, make sure you remember trigonometry, cos 150 degrees is minus cos 30. So that means it's negative square root 3 over 2. So we can plug all the values and let's complete the equation that we will have in order to figure out V prime. So V prime squared, then plus 100 square root of 3 VA prime, that's the resultant of this combination, and still plus 100 squared minus 400 squared. So let me see what I have here. And before we had 150. All right, so we can rewrite using decimals. In that case, we'll get 173.2 VA prime and minus 150,000 equal to 0. So the equation pretty looks the same, except for we have minus here. So that's why, and plus here, and contrast, so that's why we just simply express VA prime using quadratic formula and only one solution, which is in this case smaller, because obviously the airplane is moving against the wind, while here U component, which is basically parallel to C1, C2, gives a bit more velocity for the airplane, while here is actually against the direction of the motion of the airplane, C1, C2, so C1, C2, and that means that the speed, the velocity, resultant velocity is going to be slower and smaller in comparison with the previous case. All right, so we've got two values, and in order to calculate the total time, because we need to calculate the total time, is going to be d over VA prime in the first case from C1, C2, and plus the same fraction d over VA prime, but from C2 to C1. So this is C2, C1, while here what we've calculated is C1, C2. So we just need to plug the values. Instead of D, we use the same distance 1/7. And if we do that, we'll get around 5.29 hours. So that's case C. So you can compare all the times and figure out that, for example, in previous case, there was around 5.2 hours. Not significant like difference, however, it has some effect definitely, all right? And what about the first one, 5.33? In that case, it takes much longer than in the case your airplane and the wind's blowing from lateral sides. So here's should be a little adjustment. So the minimum time in that case is 5.2, so t equals 5.2 hours. When the wind is blowing from lateral side perpendicular to their C1, C2 segment. So I hope you like that. That was relative motion. That was airplane problem. I hope you did it, and see you next time.